Okay, I think I could probably wrap this up rather quickly. I've got a meeting at 12:30. It's 12:11. It's a 6 minute walk away. I think I can get over there in no time. All right, in 3 or 4 minutes. All right, so here we go. Now we are going to look at this is the I started. I had to erase this and start over. So let's just take a look at how much um, force it would take. I want you to model what I'm going to do on the page here, and then you're going to do the same thing for the water polo ball. All right, so let's take a beach ball. Let's take a big beach ball that's got a diameter of 0.2 meters. Okay, and and actually the beach ball has a mass that's much less than that. The mass of a beach ball, I would say, would be zero point 0.1 kilograms. All right, let's go with 0.15 kilograms. All right, so let's just do this calculation real quick. This will be fun. All right, so now here's what, and then we're going to figure out how much force, what's the force needed to get this beach ball completely underwater. The force to get it completely underwater. Okay, because here's what's going on. You got a buoyant force pushing up on it, and that buoyant force is equal to, and the beach ball has a mass of 0.15 kilograms, and it's got an mg pushing down this way, which is really small compared to this buoyant force. All right, and then this buoyant force is equal to rho of water. In this case, rho is equal to 1,000. This will be the same thing for your 1,000 kilograms per meters cubed, all right, times the volume of the beach ball, which is 4/3 pi, and we're going to say the radius is 0.2, let's go with 0.25. You know, it's one of those big half-meter wide beach balls. 0.25 meters times 0.25 cubed, okay, times g. That's how much water's been pushed to the sides here. And so it's going, it's trying to fill that void. The water is trying to fill in here. And so that's why it's pushing up with that force. Okay? All right. So notice I have two forces going down. So the sum of the forces to just get it underwater is equal to 0. And that would be, and that is equal to the buoyant force minus F minus mg. Okay. Well, the only force I'm trying to find is this one, so let's add F to both sides, is this force right here. So let's add F to both sides of the equation. So F is equal to the buoyant force minus the weight. So that's all you've got to do. But let's just figure out what let's just figure out what that one more time, and you can watch me do it on, and I'll do it on my calculator as if I was using one of those calculators that didn't have all the fancy functions. So this is what I'd do. In parentheses, I'd take 4 divided by 3. And then I'd put in, if you don't have a pi key, notice mine has a pi key. I'm just going to put in 3.14 then. 3.14. Notice I do everything in parentheses. Times 0.25 times 0.25 times 0.25. I'm just multiply everything out in parentheses times 9.8. That's my buoyant force. And this is huge. This is going to be a huge. Oh. Oh, I forgot to multiply by 1,000. I did all this, but I forgot to multiply by 1,000. So now you're going to see it's a huge force. Times 1,000. Ha! 641 newtons. That's like the weight of an average sized person. That's like the weight of a 120-pound person, 130 pounds. So that's 130 pounds of force that you need to smash down on there just for the buoyant force. So I've got 641 newtons minus 0.15 times 9.8, which is like nothing, minus 0.15 times 9.8. Now, it does it with the so it's 600. It's still like 640 newtons. Okay. Now, watch this funny thing. Watch if I want to. Okay, so I'm going to go 640 newtons to pounds. There it is. 100. Yeah, it's about 100. About a weight of a 143-pound person. Oh my goodness. So you're going to do the same thing with. You're going to do this exact same thing that I just did with the beach ball, trying to get it underwater, with the water polo ball. And if you hold the water polo ball underwater, my nephew played water polo in college. The guy, he's a stud. I mean, that he's now well out of college. He's in his early 30s, and he's about 6'1". Well, he's just turning 30, I think. You know, he's about 6'2", 225, built like a rock. His wife, and he still weightlifts and he still swims. You know, 10,000 meters and stuff like that. And his wife is all of about 4'11" and a marathoner. You know, so it's like every time I see him, I feel like I'm lowering the average of the humans in the room. All right. Anyway, where were we? Oh yeah, over here. Oh, it looks like you've got mail. Remember those days? All right. Anyway, some of you do. So you're going to do all of these questions. Those will be easy. How many pounds? Oh, smash down. It's like a bowling ball, right? And then the rest of this, all of the rest of these questions have to do with watching the William Trubridge and Tanya Streeter video of 60 Minutes. Okay? All right. So without further ado, I am going to, with great risk, because sometimes when I do this late, it doesn't work. All right. It's been great. More like short video. Exam the same way. We'll look at the questions. But anyway, I know this long exercise. I appreciate your patience. Break it into pieces. So you're saying this at the end, Doc? You are a dumbass. Anyway,